Now we can set up a system for increasing the difficulty as the player progresses in the game. As the player shoots more asteroids, their score goes up, and every time they sort of clear out the screen, that counts as one level being passed. And for every next level, we can increase the amount of asteroids that get spawned in. So if we look at our asteroid spawner, right, we have our FSM for that. We spawn in this number of loops, right, this number of asteroids. So we can start slowly increasing that by, let's just say 2, right? So every time that the player clears a level, this number will go up by 2. So the first level is 10, second level is 12, etc., etc. We can go to our game loop when we're on this play level state. The player can get hit, but we'll also put in some logic for whether or not the player clears out all the asteroids. So one thing I want to do too is just kind of set this color to green, right? That's us in the middle of playing the game. And you can set game over as red, right? And that's just so we can quickly navigate our FSM. Just at a glance, we know where to go to put in certain bits of logic. Play level, what we could do is check how many asteroids are currently in play. So one of the easier ways that we can count the amount of asteroids that are still in existence, right? Because it's constantly changing since the player's shooting them. One of the easiest ways that we can count the number of asteroids that currently still exist is by coming over here to our asteroid spawner. And when we create them, we could put them under a parent game object. So the parent game object could be something that we create at runtime, which means it'd be nice if we just set a start state up here, set this as the start state. Okay, we'll just call this our init, and we'll make a create new game object, and this name will be, we'll call this our asteroids container. Okay, that'll just be the name of the game object when it gets created over here, so we can actually see the name of it. And I'm actually going to copy this text and we'll name it as the same thing for its variable. Okay, so that game object will also be stored in a variable, which will be called the same thing, asteroids container. When that's done, we can send over here to spawn asteroids. We kind of continue our business as usual, except every time that we spawn this, we create this asteroid, every time we spawn in a clone, we could set the parent of it to our asteroids container. And that way, now when we play it, look at this. We have our asteroids container here, right? This is a game object. And if we drop this down, all of our asteroids are in here. And so now because they're all under this one place, what's cool is that we can actually go to our game loop FSM. And in the play level, we can get child count of, we'll make the variable, our asteroids container. And we can store the amount of asteroids remaining in a new variable called asteroid count. Okay, this should be running every frame. Now, we do still need to get the asteroids container. So what we'll do is we'll just get FSM game object, okay? And this is just going to get a game object from another FSM. So we can say that the FSM we want to get from is the asteroid spawner. The variable name is our asteroids container, and we're storing that as this, okay? That'll also be running every frame, just because we're going to be updating this relatively regularly. And so now when we press play, look at that, it says 10. And then if I shoot this, right, and as we destroy them, it says 8, 7, right, 5, what's this other piece? Oh, because these are tiny pieces, huh? Right, 4. So that helps us keep track of how many there are. And now that it keeps track of that, we can do an int compare that says, check the amount of asteroids against 0. We're going to be checking this every frame. And if it's equal to, then we'll create a new event called level cleared. Okay, and we'll add that transition here. And I'm going to move this up. It'll fire off this way. So we'll call this level cleared. And then we're going to put in a get FSM int, and then an int add, and then a set FSM int. Okay, what we're going to do is we're going to get the number of asteroids, we're going to add to it, and then we're going to set it again. So we're getting from our asteroid spawner the number of asteroids, and we're going to copy that, make a new variable called number of asteroids. Remember, this is different. Number of asteroids and asteroid count is different, because number of asteroids is the amount that we plan to spawn in. Asteroid count is the actual amount that there currently is. Like if you counted them as the player progressed, how many would there be at any given moment, right? So these two should be two different values, right? So we're getting the number of asteroids, which is how many we should make, right? And then we're going to add to it. So number of asteroids, we're going to add 2. And then we're setting that number back. We're setting it back to the asteroid spawner. We're saying, hey, if it was 10, it got that, said, okay, you're at 10. Then it added 2 to that, so that number is now 12. And then it sent it back and it said, okay, now this is 12. And then you could put a little wait action down here. And we'll say we'll wait 3 seconds before finishing down here, where we can say next, or spawn asteroids. We can send an event. And we could put in an event over here for our asteroid spawner. I'll actually scooch this up, and then we'll create an event that we can call next asteroid batch. Okay, and that'll be a global event. So I could right click on here, add a global transition, next asteroid batch, and it'll just do its little asteroid spawner logic. So over here in our game loop, we could say that it sends that event to this game object FSM. So this asteroid spawner will get that next asteroid batch. Okay, and then when that's done, we could just send back up here. Okay, now I could just send this transition up here, right? But our wires are starting to get crossed up now, right? There's a lot of this is getting kind of busy, right? We don't want this state machine spaghetti. So instead, I'm going to right click. I'm going to delete this transition. I'm not going to send back up like that with a local transition. Instead, I'm going to do a next frame event. So it's just going to wait a frame, and it's going to send a new event that we'll call back to start. Okay, now instead of clicking this and again adding a local transition, instead I'm going to right click on play level and add global transition back to start. Okay, so it'll do this and then it'll send here locally, which will just take us back here. Okay, so let's see if this works. A way we can test this more easily is if our number of asteroids starts with something like 1. Okay, so we'll start with 1 asteroid and we'll watch this number go up. Now here's something interesting. It went immediately to 3. And look at that. Now it went and added more to that. The reason for this is something that's very common in development that you need to learn very early on, and is something that you need to be cognizant of all the time, which is a sort of order of operations of things. So right now, what happened is this FSM, it ran through all of this logic of creating this and getting to this player level stuff before the asteroid spawner can finish doing its thing. So what I mean by that is that in our game loop here, when it asked us, hey, if there's 0 asteroid children, if this is 0, then just go to level cleared and then add that stuff. It got there before those asteroids were created and before that number could go up. Right, so it's kind of like if you can imagine telling somebody, hey, paint 3 pictures of a tree. I'll give you 3 pieces of paper and a green marker, and you could, draw a quick, simple tree. And even if they draw them really fast, right, even if they draw a super crappy, childish drawing of a tree 3 times in a row, it's still going to take them, maybe like 5-10 seconds at most, depending on like how absolutely terrible they go, right? So it's like you can imagine being like, okay, here's your green marker, ready, go. Okay, that's a tree, that's a tree, that's a tree, right? Now, for each one that they make, it took super quick, right? It's almost unnoticeable, especially, and so you can imagine that when a computer has to do something, it's even faster, right? Now, the thing is, there is still that moment where I'm like, and during all of that, the number is 0. That's how many trees there are. And until I'm done, it's still 0. Until like boom, and then I say ship it, then it's 1, right? So all in that moment, it's a 0. If this had time to go through and do what it needs to do and ask itself this question, hey, is that 0? Then that means you cleared the level. Then that means it's going to think that you cleared the level. So actually what you need in these systems, and this is something that you have to do in all sorts of systems and games, is finding out what needs to happen first and saying, don't do your job until. And this is, we call this initialization, right? So in our little init state over here, what I'm going to do is put in await action. This is one of the simplest forms of handling your initialization woes, which is to literally just say, wait a certain amount of time. So wait 1 second before doing anything. This isn't always your answer. Sometimes you want to do things based off of conditions. You want to say, hey, wait a minute, don't even continue until some number exists or some value has changed or whatever. But if your systems are simple enough, it's all straightforward enough, you can often just say, wait some short amount of time. Okay, so now with this wait in place, we're gonna hit play. It's gonna wait that second, and look at that. We just start with 1 asteroid. Right now it starts with 1 asteroid. If I shoot this, and I break it up, okay, now we have 3 asteroids. I bumped into that one, okay, but our system is working now. The difficulty or our progression is changing, right? So as soon as I shoot this one, right, now we should have 5. There we go, 3, 4, 5. And that number will just keep going up. And that's how we can change the progression for this little simple classic space shooter. Oh, come on, give me this. I just want to see the numbers go up. So now we should have 7, right? Yep. 3, 3, 1, 7. So looking good.